Okay, so in this video we're going to try to graph this function. This has a little bit of everything. So I'm just going to point out that anything I do to x before I plug into sine is going to cause a horizontal change. So all of this is going to affect the graph horizontally. Anything I do after I evaluate sine is going to affect my graph vertically. Okay, now if you feel comfortable with it, pause the video, give this a shot, turn the video back on and see how you did. This is the first time we've done one with all this much stuff in it, so if you feel more comfortable just working through it together, that's fine too. Okay, looking at the vertical stuff, I'm going to observe that sine would start out with a high of 1, a middle of 0, and a low of -1. First thing I'm doing is multiplying by a -2 and then adding a -1/2. Okay, so multiplying by a -2, now we're going to be down at -2, 0, and 2. But notice 1 times -2 gave me -2. So the high value here maps to the low value here. So with a regular sine function, we start at a middle value going up. Because we've multiplied by a negative, we're going to start at our middle value going down. So I'm just going to indicate that. I'll maybe even write in the word flip so that I don't forget when I'm graphing to flip that usual pattern. And then adding a -1/2 is just going to shift things down by 1/2. So 0 will go down to -1/2. -2 will go down to -2.5 or -5/2. And 2 will go down to 1.5 or 3/2. So these are going to be the y values that we'll be plotting on our graph. Cool. Okay. So let's see if we can't figure out the x values now. So I know that sine is going to do its thing as the input, which is pi times x minus 1/2, goes from 0 to 2 pi. So I'm going to solve this for x. I'm going to divide through by pi. So I get 0 less than or equal to x minus 1/2 less than or equal to 2. Now just add 1/2 to each piece. 0 plus 1/2 is 1/2, less than or equal to x, less than or equal to 2 plus 1/2 is going to be 5/2. Okay. So my new starting point is going to be 1/2, and my new ending point is going to be 5/2. Now before I just plot those, I'm going to figure out what scale I want to be using. Okay. So I can say the new period is 5/2 minus 1/2. That's 4/2, which is 2. Let's just double check. That should equal 2 pi divided by the number we were multiplying by. Yep, it checks. So the new period is 2. That means the new increment is 2 divided by 4, or 1/2. So I'm counting by a length of 1/2. Okay. So I can go ahead, I'm going to mark off 1/2, which is my starting point, but now I know that's also the distance that I want to have in between my consecutive points. Okay. Doesn't matter to me what scale you use on the x-axis. I don't care if your 1/2 interval is that big or that big, but if that's 1/2, you got to go twice as far to get 1. Once you've established a scale, you want to respect that. Okay. So 1/2, I'm just going to count by 1/2 then. So my x values will be 1/2, 2/2, 3/2, 4/2, until we hit 5/2, which is our ending point. And as I copy these down here, I'm going to just reduce some of them. 2/2 reduces to 1, then I've got 3/2, 4/2 reduces to 2, and then I've got 5/2. So those are the x values I'm concerned with plotting. Okay. And then let's see, we said the y values we cared about were all these multiples of 1/2. So what I'm going to do is I'm just going to use each tick mark here is 1/2. So that's 3/2 there. Notice I'm using a different scale on the x and y axis. That's totally fine as long as I'm consistent on each axis. So there's -1/2, 2, 3, 4, 5, -5/2 would be down here. Excellent. Looks like I need to erase a few of my calculations to give me room for that graph. Again, not absolutely necessary, but I like to draw in dotted lines at the heights that are my important heights. And then we were starting at 1/2. Oh, and let's just remind ourselves, we still did this flip. Okay, so at 1/2, we're at a middle value, and then we go down. So then our next point is a low value, back to a middle, up to a high, back to a middle, and then I connect the dots. My marker is squeaking. Okay, notice I do want to be careful here. This is why I was sort of careful about the scale here. This distance happens to equal my increment. So if I come back here, I'll actually cross the y-axis here at 0. If you're careless in sketching things, you're just sort of like, oh yeah, and then it continues, and it, goes like so, and you cross the y-axis, sorry, it crosses the y-axis at 3/2. You cross it at a different height. So do try to be careful. You can either just have arrows to indicate that you're continuing, but if you continue far enough that you're crossing the y-axis, make sure you're doing it at the right place, because the y-intercept is an important point on our graph, so it's very misleading if that point happens to be in the wrong place. So be consistent with your scale. Doesn't have to be the same scale for the horizontal and the vertical, but it's got to be consistent on the horizontal axis and consistent on the vertical axis. Okay?